We're going to finish the notes for this unit. We're going to talk about reactions that go to completion, talk about the common ion effect, and talk about a real-world application of equilibrium. So far we've been talking about systems at reversible reaction, systems at equilibrium. But if you have a product leaving the system, it will go to completion. It will not reverse. And so there are two ways that we're going to talk about how a reaction can go to completion. This first reaction, if you have the formation of a gas, so this example here, you have carbonic acid, it forms water and carbon dioxide. This is a decomposition reaction. You can see that the reaction is going to completion. It's not reversible. We have a single arrow. We're not going to have products reform the reactants. The gas will escape, and then you will not have that product to collide with the water particles and reform the reactant. This is going to go to completion. In our second example, again, we're going to have a reaction go to completion. We have, in the second equation, a total ionic equation. And it's a double displacement reaction. This is showing you a total ionic equation of a double displacement or precipitation reaction. And so we have the formation of a solid. The formation of a solid will result in a reaction going to completion. So two ways for a reaction to go to completion is if the reaction forms a gas or if the reaction forms a precipitant, a solid. Then you will not have those products to reform reactants. In an equilibrium system, we can also have what's called the common ion effect. And so the common ion effect, we're going to show you with sodium chloride ionizing, forming sodium ions and chloride ions. If we add hydrochloric acid, what I'm actually adding to the system are hydrogen ions and chloride anions. And so if I look at this system here, this ionization, I have chloride ions here and I have chloride ions here. I'm adding a common ion. I'm adding chloride ions. So if you add something, thinking about Le Chatelier's principle, it's going to go up, up, and shift away. And so you're going to have the sodium chloride precipitate or fall out of solution. So by adding hydrochloric acid to the system, we're adding a common ion, the chloride ion, and will result in the formation of sodium chloride solid. So the definition of the common ion is the addition of an ion common to two solutes brings about precipitation or the formation of a weak electrolyte. So I want to end our notes on equilibrium with a real world application. And so we're going to look at chicken equilibrium. And this is, if you look at this whole big equation here written down here, you don't have to write this down. You can just listen. This is an equilibrium system, and it just keeps going. There wasn't room to put it on one slide, so it's one big equilibrium system. And so we have chicken breath, carbon dioxide over here. And chickens do not sweat. When they are hot, they pant. And so in the summer, egg producers noticed that egg shells were thinner and more fragile. And so a University of Illinois student used Le Chatelier's principle to try to figure out how in the summer hot months they could fix this, make the eggshells stronger, thicker, not so thin and fragile. And so what he gave, this is carbonated water. And so chicken breath is in this whole equilibrium system with the eggshell. Your eggshell's all over here. So if chickens are panting because they're hot, then the amount of carbon dioxide given off is it's going to shift. You're taking this away when they're panting. You're taking that away. The equilibrium shifts to the left. And so that's why the eggshells are thin. When they give the chickens carbonated water, when they give them this carbon dioxide in solution, when that increases, it shifts the equilibrium to the right, and that will in turn make the eggshells stronger, producing stronger eggshells. So this was a real world application of how a U of I student used Le Chatelier's principle to help egg producers make stronger eggs. I just want to remind you that your review guide for chapter 17 and 18 is due tomorrow. Your practical exam is on Thursday. We will go over the review guide in class tomorrow, and I will also offer an additional review session after school tomorrow. You should be working on your review guide. If you have that done, then you should be checking on your final exam review guide sheets, checking your answers with those. The answers can be found in Schoology. You should be working on something quietly for the rest of the class period.